Hi everybody, in this video I would like to tell you about some selected examples related to bending moment or normal stresses in beams. In this example 5.3, we have a beam element. Beam element is like this one, and in this beam element we have concentrated load P equals 50 kilonewton, which is located from A to some position 2.5 meters, and the total length is AB is 6.7 meters. Okay, and we have another distributed load. Load intensity is 22 kilonewton per meter. Okay, this one is supported on the left side is hinge, right side is roller. Okay, this kind of beam we have, and the cross section of beam is like this one, and the height is 700 millimeters, and width B is 220 millimeters. Okay, in this case we would like to know some value related to maximum available stresses. We would like to know maximum available stresses in beam. That's our final question. Before doing that, let's have a quick review about formulas related to stresses in bending. Okay, we have this kind of relationship. The strain is given minus kappa y, and kappa is equivalent like this one, and sigma equals expressed in this way, minus E kappa y, and of course sigma, this value is maximum moment is divided by section modulus. Section modulus is divided by I over C. In the case of I, in this kind of shape, rectangular section, and cross-section area is like this one. In this example, we will apply section modulus and this formula. We can apply both formulas. Before doing that, we must find maximum bending moment. In order to find the maximum bending moment, At first, we must find this kind of RA, RB, reaction force at this point. Of course, this kind of distributed load is equivalent to like this one, this kind of concentrated load, which is located in the middle of the beam. Okay, then finally we can apply force equilibrium, sigma F equals 0, and moment equilibrium, sigma M equals 0, and maybe we can draw free body diagram like this one. Let's say RA and some value, this kind of value. This distributed load is located like this one, and downward direction is positive V, and this kind of direction is moment M. In the case of on the left side, when element is located from A to that point P, then, or if it is located in the right side there, then we can draw free body diagram like this one. Very similarly, RA is like this one, and distributed load P is acting somewhere there, P, and of course we can do V is located like this one, moment is like this one. Okay, when you calculate both cases, in this case x located this distance is x, let's see. X locates 0 to 2.5. In this case, x locates 2.5 to, this distance is 6.7. Okay. By applying the relationship under this condition, then we can find finally shear force diagram is like this one, and bending moment diagram is like this one. Okay. Our purpose, we would like to know maximum bending moment. This one is very important, maximum bending moment. Okay. Because we would like to know sigma value. Sigma equals moment is divided by section modulus S. Okay, moment is given like this one, and next one we would like to know section modulus. Section modulus is I over C. In this case 1 over 6 BH squared. 1 over 6 BH squared. 1 over 6 B is 220 here, and H equals 700 millimeters and squared. Of course, in this case, the unit is millimeter 3. Be careful about the unit, because we have different kind of units there. Okay. Then we can substitute the S value there and M value there. Then finally, we can find sigma value. Okay, I would like to repeat, summarize this example again. Firstly, our final goal is to find the sigma value like this one. The sigma value is given by M over S, and S is section modulus. Section modulus is defined by like this one. And important thing is find maximum bending moment. In order to find the maximum bending moment, firstly draw free body diagram like this one and find RA and RB value by applying those relationships. And next, draw shear force diagram and bending moment diagram like this one, and in order to that we divide into two parts, on the left side, on the right side, and draw free body diagram, apply force and moment equilibrium relationships. Then we can calculate V and M. And next, in this case, in this range, we can calculate again, and finally we can draw this kind of bending moment diagram and shear force diagram. When you watch shear force diagram, maybe it's changed dramatically at this point, and of course at this location we can find maximum bending moment. Okay. Next, we would like to find section modulus. Section modulus in the case of rectangular component, we have 1 over 6 BH squared, and we have the data related to width and height. Then finally we can get section modulus. Finally, substitute this formula to this formula, S and M value, then we can calculate sigma value finally. That's it for example 5.3. Okay, now let's start example 5.5. In this example, you would like to know the size of the beam. In this case, beam is like this one, located like this one, or maybe it's made of wood, and distributed load is given 4 kilonewton per meter, and length is 3. and maximum allowable stress, bending stress, maximum allowable stress, maximum allowable bending stress, allowable. This one is given. We know this one. And our goal is to find when you see cross-sectional area, if it is like this one, okay, width is B, height is H. We would like to know BH. We would like to know B and H. Of course, in this case, we cannot find exactly this one, but if we have some table in some appendix or table, appendix somewhere, appendix F, there is a table. In the table, you can see the combination of the beam and maximum allowable section modulus. Section modulus is given. Okay, let's see step by step. Okay, in this case, we have this kind of beam element is given like this one. Let's say this one. Of course, in the beam element is given like this one. Let's say Q is given like this one, distributed load. Let's say this distance is L. Okay. We know very well about that to find shear force diagram and bending moment diagram. At first, to find this kind of reactional force, and after that, when you select this kind of free body diagram, and V and M, we can calculate like this one. And when you do that, then we can draw this kind of shear force diagram. Maybe in the middle we have this one, shear force diagram, or bending moment diagram. Bending moment diagram is like this one. At this point, the bending moment is maximum. Okay, if we apply this kind of equation, this kind of relationship, we can calculate like this one. But intuitively or mathematically, it's also available. Constant one is integrated, then linear one was integrated, then second order curve is available. At this point, maximum bending moment, and max equals Q, let's say L square over 8. This kind of value is available. QL. And after that, we would like to know section modulus, or maximum allowable stress, bending stress is maximum bending moment is divided by section modulus S. Okay. When I change this one again, and maximum bending moment and the sigma maximum allowable bending moment is like this one. We know maximum bending moment, and this one is also given. Then we can calculate S value. Okay. Section modulus, when section modulus is given, then we can find proper value, proper combination of B and H in the appendix H, which correspond to calculated value of section modulus. Okay, just select that. Then finally, we can find in the appendix F, B and H combination. Or if we don't have any appendix, then maybe this one is data book. In data book, we can select the combination B and H for the material itself. Okay, that's it for this example. In this example, I would like to summarize. We have this kind of configuration, this beam element, and externally distributed load is given like this one, and we would like to know this kind of cross section, B and the size of cross section, B and H. In order to find that, firstly we calculated shear force diagram and the bending moment diagram, and we found maximum available maximum bending moment is like this one, and we apply this kind of relationship. Sigma is given, and finally we have this kind of one, and we can calculate S value, section modulus. When you have section modulus, then you can refer the data book, then finally the appropriate combination B and H can be chosen. That's the process for this example.